Hi everyone, and I love being the last speaker. That way I get to isolate, the people that actually want to hear me, and I'm not just, intermission towards the next speaker. So today we're going to talk about testing text-based models, a holistic approach, and we're going to start off by talking about classic NLP models, and then we're going to move a bit more towards LLMs, and we'll see there's a lot in common, even though there are some major differences. So a bit about me. So my name is Tannor, graduate of the Israeli Talpiot program, for those of you that know it. I got my machine learning foundations from a group within the Israeli Defense Forces called MMM. We were very much into competitive machine learning, and a lot of my foundations came from Kaggle and similar competitions. I'm proud author of AugBoost, together with Professor Leo Rokach, that I know I'm not his only student here in the audience. Which is an improvement of XGBoost, you can say, using some very interesting techniques. And I'm co-founder and CEO at Deepchecks. I used to say that I transitioned from machine learning to AI when we founded the startups, but now that AI became kind of a more technical mainstream term, then I could say a lot of my team transitioned to AI, and not only me. Deepchecks was founded 3 years ago, backed by some amazing and leading investors. And we're building what we call everything you need for continuous machine learning validation. So just to mention kind of a bit what that means, it means testing and making sure the machine learning models are doing what they should be doing at a few different phases, like testing, CI/CD, monitoring, auditing, the pretty extensive approach where I think we're most famous for the open source testing package, which we released and has gained a lot of popularity in the last year and a half since it's released. We've recently released a few interesting things, including open source monitoring and so forth. But in regards to this talk, we recently released an NLP module, which we're now expanding towards LLM evaluation. So let's just dive in a bit. What is Deepchecks? So the idea is we create these types of figures, graphs, fairly automatically that can be customized. But the idea is we're doing this with, it's an open source for data and model validation, where there are checks and conditions that we create. So a check is some sophisticated logic that runs, and then a condition means something that says when it's okay and when it's not okay. We focus on a few different types of data, on NLP, tabular data, and also on computer vision data. So what are we going to talk about today? So we're going to talk about some common data and model issues, including integrity, drift, shortcuts, segment degradation. I think some of these have been mentioned in some of the previous talks earlier today, but a lot of our approach is to be very extensive in the type of things that we test. Throughout the whole talk, the link to our GitHub is going to be at the bottom, so whenever you're bored, just kind of go in. You can star us if you really want. After talking about the different types of problems, we'll talk about how to find them, how to detect them, and how to deal with them. And at the end, we're going to talk about how this applies to LLMs. So some common data and model issues that we're going to talk about. So there are a few different phases. As you can see, there's the phase of acquiring the data, which is right at the beginning when you just get it. Then there's the training of the model, and then there's the production phase. So for each one of these is a bit different. So you can say the data integrity is right at the beginning of the acquisition. Once you split into training, validation, tests, then that's everything that has to do with data distribution. And then there's the model evaluation phase, which is you need a model, of course, to be able to evaluate the model. The idea is you want to check any type of issue as soon as you can. You don't want to wait till production to check if you have a problem with data integrity. So just like one example we can give is look at this out of vocabulary. So imagine I have embeddings, and I'm trying to look up the embedding of a word that didn't exist when I trained. So problem, right? So this is one example, but then there are many different types of issues. Some relate, different issues relate to the different phases that we're looking at. So that's a lot about what we kind of deal about. Now we're going to talk about some examples that relate to NLP. So if we look at data integrity, these are, when you take a BERT tokenizer, so it turns out that BERT can miss some uncommon tokenizers. So tokenizers, just for some background for those of you that are a bit rusty. So the idea is, you want to separate the words or the sentences into tokens that are in the vocabulary that you can deal with. So when you're breaking them up into tokens, then sometimes it can work not well, when you have uncommon characters that are within the words it's trying to tokenize. And it's, of course, better to know that before training a model rather than after. Another field that was mentioned earlier today is data drift, concept drift. Data drift is when there's a shift in general the input data that you're getting. Concept drift is when the prediction change, the Y or the prediction given the data changes. So it could be like the meaning of what your prediction changes is concept drift, where data drift could be, until I was in US, now I expanded from US to Japan. The input data is, different just because I have, more from a different population. So within NLP, it's always the most interesting examples to look at. So let's just look at this, at these tweets. So you can see, the searches for Twitter hiring, Twitter firing, kind of over time. So you can see usually hiring is more interesting. And then there was a peak a while, when Twitter was doing a lot of firing, that a lot of people were searching for it all over the world. And I don't know, maybe the peak that has, the Twitter hiring at the same time, might have been even a typo, right? People searching for firing, and I by mistake did hiring. So the context of Twitter hiring during that peak is very different. That's a classic example of concept drift. Now, to the next field I want to talk about is shortcut learning. So you can see this text from Wikipedia, and then NLP works is say from my aunt. So which one seems more credible? The Wikipedia one, right? But so what you could have is just automatically learn if you have, a model that's learning without any constraints. You could say, okay, long texts are, true, where short texts are false. And these types of things, they seem weird, but they do tend to happen deep within models without, supervision. Here's another example for symptoms classification. What is a symptom? What isn't a symptom? So I don't know if any of you noticed it kind of before I mentioned it, but everything on the right has 3 words, and on the left doesn't. So with this type of sample, you can learn, if there are 3 words, then it's not a symptom. This effect is called shortcut learning. It's most commonly known within the area of computer vision, where there's the classic example of a husky, which is on snow, and then it's classified as a wolf, because usually you learn the background instead of what you're really interested in. Another example that we're looking at in terms of things to look at in an NLP is model degradation segment. A segment that the model degrades in. So if the model tries to understand brand awareness for Netflix, and then you all of a sudden have a phrase like Netflix and chill, where it didn't really exist before that, you might mistakenly think, oh, young people love Netflix because they're really excited when you write something like Netflix and chill, where in reality the brand could actually be going down at the time. So these are all these different types of issues. I want to talk a teeny bit about how to find them, and then we'll talk to how this all connects back to the LLMs. So, for the categories we talked about before that, I would separate into integrity, then distribution and performance. So like integrity, sticky keys, gibberish, sample leakage. These are all things that you only need like that one big chunk of data at the beginning. So what we tend to do is, at least for NLP, for integrity, we like Deepchecks to keep it unstructured, whereas for the distribution and performance part, we like to move it first towards structured data and then analyze it and treat it as structured data. So let's talk a bit about how this works. So I'm talking now with a focus on NLP, but any unstructured data is the same idea. You want to convert a single sample to be something that can be represented as a number, vector, category, etc. And then it's much easier to work with. So there are a few different types of transformations you can do, or ways to look at structured data. The most straightforward thing is metadata, right? If you're looking at text and you know who wrote it, when they wrote it, whatever, that can be structured data. Then the next thing could be properties. That's a major focus for Deepchecks. When you do whatever sophisticated calculation you can do, use a model, whatever, you end up getting a very specific number, and that's it. So that's what we call a property. It has some advantages. We'll talk about it. And then there's embeddings, which I don't think there's anyone in the room that's never heard of embeddings. So you use something like a neural net that automatically creates embeddings that have their own meaning, which are a bit less explainable. So given the length of the talk, I'm not going to dive into how we do or how we treat each of them, but I'll give some properties about the different ones. So the metadata is, of course, very accurate. It helps you segment the data that you're looking at. So if you want to look at, data from a specific geography or whatever, it's amazing for that. but it doesn't look into the text, and it's missing a lot of properties. For the properties themselves, it's hard to get good accuracy. If you manage to get good accuracy, that's really the best you can have, because it describes the test, it's explainable. You can talk about things like, I don't know, toxicity, does it contain PII, things like that. But it's a road less taken. We took that path. It's not as common. And then embeddings is very common. It's very accurate. But then at the end, you can have some this and this value number 32 is 27.32111, and you can't say anything with it. So it really can help do things that kind of make sense. It looks good in examples, and it's a bit hard to work with. But anyway, we believe in a combination of all of them. So just a bit about the NLP package we released now. So it's open source. It addresses many of the issues I talked about and more. And you can all just go into the Deepchecks GitHub and download it, play with it, and we're really proud of kind of what it did and the expansion of the tabular. But I want to say a word about how this connects to the large language models, which is pretty significant trend in the recent times and does need a ton of validation, testing, etc. So what's different about the LLM evaluation setting? So first of all, there's a change in what we validate. It's not the exact same thing. So there's no training data at all. So in many cases, we already have the model. We're just creating like the prompt before, after, and so forth. And it really is important to train the entire app. It's always important to take the whole business context, but here you really just can't ignore it. You really have to see the input and the output of the app. And then for analyzing the outputs, it turns out that it's just as important as the input. Like if you want to see, is my model giving away personal information that it shouldn't be, that's in the output, not in the input. So it's not that the output is just like a 1 or 0, but the output is just as interesting to analyze. And then the users are a bit different. This took us a while to understand, but even though there are data scientists that use large language models, we really have to cater to the developer and the executive for large language models. They're both very interesting and engaged. And in some cases, the data scientists just aren't involved in every single step, or it could be an organization that doesn't even have them. But a lot of the principles I described earlier, they still apply. So I'll say a bit about our approach towards the evaluation of LLMs and how we're taking what we built in NLP and using it for the evaluation of large language models. So the idea is we calculate as many properties as we can, just like the approach for classic NLP, but we also have some extra ones, like was the question answered, given the prompt and the response. Then we take those properties, which is now tabular data, and we use that to create a UI that's meant for the both developers and data scientists and the management. Where what we're really doing is we're enabling a thorough understanding of what is or isn't working, and enabling to make decisions like, is the LLM at a good enough state to deploy or not? Do we need to make an improvement? Which areas aren't good enough, et cetera, et cetera. So if you'd like to kick the tires and try it out, the LLM evaluation beta that we have, then please reach out. We just opened an ambassador program, and you know where to find me. I'm not a very hard person to find. So thank you very much in the meantime.